When should you apply interrupt masking in your code? Imagine you're working on a microcontroller project where timing is everything. You need to make sure certain tasks happen without interruption. That's where interrupt masking comes into play. Interrupt masking is used when you want to temporarily stop specific interrupts from interrupting your current code. This is especially important during critical sections where shared data or hardware registers are being accessed or changed. If an interrupt occurs during these times, it could cause data corruption or inconsistent system states. For example, if your code is updating a shared variable that an interrupt service routine also uses, masking interrupts ensures the update completes without interruption. This prevents race conditions, which are errors caused when two processes try to modify the same data at the same time. Another situation is when you are configuring hardware or peripheral devices. During setup, you might want to mask interrupts to avoid accidental triggers or conflicts. Once configuration is complete, you can unmask the interrupts to resume normal operation. Microcontrollers often support different levels of interrupt priority. Masking lower priority interrupts while servicing higher priority ones can help manage real-time responsiveness. This way, critical tasks are handled immediately, while less urgent interrupts wait their turn. If your microcontroller does not support nested interrupts, masking is essential during an interrupt service routine. Masking prevents reentrant calls or nested interrupts that could cause stack overflow or logical errors. In most systems, masking is done by setting bits in specific interrupt mask registers or by using special instructions. For example, in microcontrollers based on the ARM Cortex-M architecture, setting the primask register disables all interrupts except the non-maskable ones. In AVR microcontrollers, clearing the global interrupt enable bit masks all interrupts. It's important to keep the masking period as short as possible. Long masking times can cause missed events or delays in handling important interrupts. The goal is to protect critical code sections without sacrificing system responsiveness. In summary, apply interrupt masking when you need to protect critical code sections, manage interrupt priorities, safely configure hardware, or prevent nested interrupts that your system cannot handle. Using masking wisely helps keep your embedded system stable, consistent, and responsive.